Hello, and today we're going to look at loops. Right, what I'd like you to do is I would like you to get a pen and paper, and I'd like you to complete this challenge. So you see this square on the slide here. You are going to create a program that's going to draw that square. You're not going to draw the square yourself, obviously, with a pen and paper. We all know you can do that. But you're going to create a program that will draw that square. And this is the code you need to know. So, you need to start drawing as pen down. Each side is 30 pixels. And of course you can use directions such as forwards, backwards, up and down. And each corner is 90 degrees. Okay, pause this video and create the program to draw this square now. Well done. Okay, welcome back. So, hopefully your code looked like this. Now, some of you may have been clever and work out, actually, I can use a loop. And some of you, without a loop, you would have had exactly the same result. Okay, so either way, if this was put into a program, you would have made a square. Okay, so without a loop, you can see it's pen down, forward 30, right 90, forward 30, right 90, and blah, blah, blah. Now, pen down, repeat 4 times, forward 30, right 90, and repeat. So with the loop, it wasn't repetitive and it was 2 less lines of code. And that's what we're going to look at today, is the beauty of loops. So we're going to understand loop structures and use them effectively in a given programming scenario. Now we're going to understand the 2 looping structures and their differences, apply a scenario and create a program to show all. So underneath this video there is a link to the task that you're going to complete today, which you can complete in Python. Now what are loops? Loops are fantastic, okay? Because rather than writing the same lines of code over and over again, and in some cases we might need the same lines of code to repeat forever. Okay, so how can we write infinite lines of code? And more to the point, why would you want to? Okay, so loops are there to make those jobs easier. So as you can see, if you've used MIT, App Inventor or Scratch or Microbit, you will recognize this block code here. So you can see it's got a while loop that literally clamps around all of the code here, and then the person here has made their code, and basically it's got the while loop to start and stop when the condition is met. Okay, now what has that got to do with this robot arm here? Okay, well, robots, particularly robot arms, are used in manufacturing production lines. And they are programmed on loops. So one time, for example, like car factories such as BMW, Nissan and Ford would have hundreds and hundreds of people working on a production line. And they would be doing the same job repetitively. Okay, most of them doing the same job repetitively, not all of them. Some of those people were very, very skilled engineers. Okay, but there's some people that were doing the same job every single day. So what they did was they got robots to do it. Why did they get robots? Well, to begin with, the robots can be programmed on a loop. Okay? And the robots can execute exactly the same task as a human, but they can do it much faster and much more efficiently. And they're programmed to do it over and over again, and they don't get exhausted. So in actual fact, car production plants are now producing far more cars and arguably better quality cars because they've got robots doing the job on a loop. Okay, so now the loops are used to repeat the process. So rather than repeating the same process over and over again, they're automating it and they're continuing it forever or until the condition has been met. And an example would be, as I said, a car production line in a factory. So the humans were paid to do the same job, do the same thing all day, every day, and now they have the robots. But the initial startup cost, obviously, of the robots, to buy the robots to begin with, and to get the people to program them and, you know, pay people to maintain them, the initial startup cost is very, very high. But in actual fact, overall, they work out cheaper in a way, because obviously humans will get sick, humans need holidays, humans have families, robots don't. So these robots can continue to work 365 days of the year, you know, probably 24 hours a day, and not need a break because they're robots. Now, obviously, as I said, robot arms are programmed on a loop to do the same task, but faster, much faster. So, for loops. Now, we're going to look at some for loops here. So, after the for loop executes the flow of the control, it jumps back to the increment statement. Okay, so the for loop, and we'll show you how to do this. This statement allows you to update the loop and control the variables. So it's true that the loop executes the process itself, and the body of the loop then increments the step, and then again the condition. Okay, so we've got an example here. Okay, so we've got these trainer brands, and a for loop, what it will do is for each of the brands in the trainer brand array here is going to print it, and that's as simple as that. So if we was to take a look at that, okay, so I've got this here, just minimise that. Minimise that background there. So here we are. So we've got, so I'm just going to make the same thing, okay, trainer, brands, and I'm going to make my array. So I'm going to put, I'm not going to put as many in, Nike, Reebok, ASICS, okay. So there we go. Now, this is when we put our for condition in. So for brands, okay, in trainer, brand, so in the array, okay, print brands. There we go. Right, so if you're following this, so execute this code now, and make sure obviously you save it into a folder. And oops, there's a problem there. So it says trainer brands is not defined. Okay, so I've made a mistake. Okay, let's take a look at the mistake that I've made. Right. Okay, just going to pause this video a moment. Paused it for a second. I realised I forgot to put the equals straight away. Okay, right, there we go. And you can see it repeats every single one of them. So if I added something else, okay, so if I added, let's put Adidas there. Okay, so if I added that in, and obviously it's going to print that. Okay, right, so what I'd like you to do, okay, is I would like you to pause this video, and I'd like you to test it out yourself and make your own array. So like maybe you want computer brands, films, or anything like that. So pause this video now and give that a go. Welcome back. Okay, so now we're going to look at the next thing. So it's the range function. Okay, so the range function, basically it says the range is built up a function in Python, and what it does is it starts and it goes up to and it steps, and then basically it delivers that result. Okay, so what I'm going to do now is, following this here, okay, we're going to look at this, and you can see here that for count in, and it's got an array of numbers here, it prints I can program. Now it prints I can program 8 times, not 7. Why is that? Well, it's because a computer will always start counting from 0. So if I was to make a program similar to this, okay, for count in, and I'm just going to put in brackets here, okay, no, I'm not going to put in brackets, so I'm just going to make the same thing here. So if I was to put 1, 2, 3, 4, 5, 6, 7. Okay, right, I'm going to test out print. Okay, I can program. All right, so I'm going to do the same thing. So I'm going to look at the result this way, so without the 0, and see what happens. Okay, now it's printed. I can program 1, 2, 3, 4, 5, 6, 7. Okay, and you can see I've got 1, 2, 3, 4, 5, 6, 7. Now, why has it done that? Okay, now the reason why it's done that is because it's printed. I can program for every single value in that array. Okay, so the computer's not actually counting. It's not necessarily starting from 0. It's literally printing. I can program for every single value in the array. Okay, so that's what I've asked it to do, and that's what it's doing. So the same thing, if I was to put 0 here, you can see that it's printed one more I can program. Okay, right, now next, moving on. Okay, so moving on, now we're going to look up the range in terms of the range loop. Sorry if I missed one. Oh, up to. Okay, sorry, I forgot this one. So I'm going to do this one here, right? So I'm just going to, no, I'm not going to delete the whole thing. What I'm going to do is I'm going to edit the program, okay? And I'm going to put in range 7. Okay, so this is the up to, so it's going to count up to 7. So we're going to look at this now, and whoops, 4 count. Oh, sorry, I forgot to put the range. There we go. See, look, even I make mistakes, and I feel like when I'm on a video, I'm under a little bit more pressure. Okay, so here we go. I can program now. 1, 2, 3, 4, 5, 6, 7. So it's gone and counted up to 7. So it's 1, 2, 3, 4, yep, 7. There we go. So it's done that for us. Okay, so moving on next, we're going to go and do step. So in terms of the step, for example, so moving on to the step. So what we can do here is we can change this here. 4 count in range 7, print count. So what I'm going to get it to do now is print the counts. Okay, so you can see it's counted 7 values, but as you know, computers start counting from 0. Okay, so it's printed 0 to 6. The same as if I was to change this to 10, it's going to print 0 to 9. Okay, so do that. There we go, 0 to 9. Okay, right, now, so there's a couple of exercises here. So we've just done that one. And here we can actually split it in terms of a sequence. So I'm going to put 10, and then I'm going to put 2 here. So like I said, you can follow along with this, pause the video at any time and see what it prints. And it hasn't printed anything. Okay, so for count in range, let's try what it's got on there then. 2, 2, 7. Okay, so 4 count in range. Okay, and there we go, 2, 4, 6. Okay, so why 6? Well, it's counting up in, so basically what we've done is we've asked for it to count from 2 to 7, and it stops at 6. Okay, so because obviously the computer, as we know, basically counts from 0. Okay, so if I change this from 3 and then I put 9, let's see what happens. There we go. Okay, and it stops at 8 because, like I said, the computers start basically count from 0. Right, so the next one is we can put a step in, so we can put 3. So we can start at 2, go up to 36 in steps of 3. Okay, so I'm going to basically follow what's on the PowerPoint here for you live, and obviously you can do your own thing. So there we go, up to 35. So as we said, again, computers count from 0. So I want to start at 4. I want it to go up to 100, and I want it to go in 5s. Okay. There we go. So 4, 9, 14, 19, up to 99. And like I said, play around with it. Do what you want to do. Okay. Doesn't matter how big the numbers are. You might want to see it roll and roll on the screen. I don't know. Okay. Right. Now, break and continue. So now what we can do is we can get our loops, okay, to break. Okay. So we can actually put a condition in where the loop stops, and for this we use break, okay, but this can only be used in a loop. So I'm going to put 4 count in range, so we've got it on the PowerPoint there, starting at 1 up to 20. Okay, why don't we start at 5 and go up to 200, because I want to. All right, and I'm going to put an if in here. Okay, so if count equals to 150, break. Okay, and that means stop. So that's my condition. All right, so I want the computer to count in range from 5 to 200, and if it reaches 150, I want my loop to break. I want the loop to completely break. Okay, so then I'm going to get it to print the count, because if I don't, I won't know what it's done. All right, so this is how we see the result. And there we go, it stopped at 150. Okay, so it counted all the numbers and stopped at 150. So that's how we see the result. So for example, if I didn't get it to print the count, okay, there we go, it's done it, but we haven't seen it. That's why we need to print it. So we need to print to see what's going on. Right, so if you want to give that a go and pause the video now, obviously you can do. Now, there's also another condition called continue, okay? And it's when we put a condition in to say continue, all right? So, like here, we've got... if the condition is met at 150, break, well, I'm going to put continue. Okay, so print count, run, and there we go. It does exactly what I've said. Okay, so if the count reaches 150, continue, and that's just basically break and continue. So you may have 2 conditions. Okay, for example, if you're making a program, and for example, you may say, like I've done a clubs thing, so with my older year groups, and basically I've got them to make a program where a teacher can enter their name and a club they want to run, and what day they want to run it. So I put a condition in where I said, if there's 3 clubs on that day, they can't run the club. That's the condition. So that would say break. And then, but if they choose another day, like Wednesday, continue. Okay, so there we go. Right, now what I'd like you to do is you're going to submit this as an assignment. Okay, I want you to complete the loop challenge sheet. Okay, and like I said, you're going to submit this as an assignment. Now what you need to submit as the assignment basically is print screens of your code of what you've done today. Okay, right, very best of luck.